Welcome to lesson 11.4. Before we get started on the central limit theorem, let's review what we learned on 11.3, which went over the normal distribution. Number one says the weights of 225 high school baseball players are normally distributed with a mean of 175 pounds and a standard deviation of 14 pounds. Approximately how many players weigh less than 161, and what percent of the players weigh between 147 and 203 pounds inclusive? All right, so let's first take a look at part A here. Now, with my calculator, and while I'm here, let me go over to our digital classroom. You can go down to either daily, weekly links and select Desmos pre-programmed graphs, or you could open up this document here. And in between number 3 and 4 on the left, you will see the calculator listed in a different color blue there. Now, what I will do now is I'm going to come over here and click on, here's our calculator sheet. If I go all the way down to the bottom, there's AP statistics. And when you click that, it should open up this chart. And so for the normal distribution, one thing we've done is to simplify things. I have it plugged in here, and we could find out all of our information we need by saying, okay, our mean here is 175. The mean, that's the symbol mu, if you remember, 175 pounds. And so I'll put that in as my mean, 175. And the standard deviation, sigma here, is 14 pounds. So we put that in, 14 right here. At that stage, I'm going to click this little plus to zoom fit. It'll show me, here's my chart, and this over here is the cumulative probability, or the CDF, represented on the side. If we're wanting to know how many players weigh less than 161, that means the maximum weight is 161 pounds. So we want to know all the values that are 161 or less. So basically everything from 160, let me scoot in a little bit. That would be 161. Everything from this area over. Okay, so the way to do that is just right over here, you put 161, and it would show you that's the area, which happens to be 15.8%, or actually I would say 15.9. Let's just say that's approximately, this will be approximately 15.9% of players weigh less than 161 pounds. Now, oh, that's supposed to be a B right there. Okay, so you're looking, and this number does not show. Well, that's 15. That looks like the right answer there, except it's not. This is not a percentage. It says here we have 225 players. So really what that means is I need to take 225 and multiply by that 15.9%. Whoops, 15.9%, which is the same thing as 225 times 0.159, which means approximately 36 players will weigh 161 or less. So that would be our answer to part A there. Now on part B, by the way, we learned a formula using Z values if you want to go back to the standard normal. And I don't know if you remember, but we said the Z, you would take any of your values, which in this case, or you would take your particular value you're trying out, which in this particular case is 161. The formula, it just had a little X there for any random value minus, let me just write out the formula, divided by sigma. And so this is, if you wanted to use this, you would have had 161 minus the mean of 175 divided by the standard deviation of 14, and that would have gotten us -1. And so what we could have done is on the standard normal, that means it's a normal distribution with a mean of 0 and a standard deviation of 1. You would look at the Z value of being left 1. So I'll show you, this would give us the same exact value. If I change this to a 0 and this to a 1, and I wanted to, let me go here, look at the values from -1, you see it's the same number. So that also would have worked. All right, let's take a look now at part B. It says, so going back to this 225 with a standard deviation of 14, and we had here 161. That's what we had last time. What did I do here wrong? Let me pause this just for a moment to fix what I've got wrong here. I put in the number of players. It's 175. There, let me correct this to 175. Okay, there we go. A mean of 175 and a standard deviation of 14. There we go. We're back on track. All right, part B, it says what percent of the players weigh between 147 and 203? So I put in 147 and 203. And we want to know how many players weigh in between these weights. So we're looking at the area in between. Here would be 147. If you zoom in, you'll see that that is 147 there. Zoom in a little bit. Yep, 147. And this weight over here, that would be 203. So what percentage of players? Well, it's this area under the curve in this area, which is represented by 95.4%. So 95.4 is approximately 95%. That would be the value there. Okay, again, if you wanted to use the Z numbers, what you would do is your Z for your left bound, let's call it the Z score, I'll just do a Z with an L here for left, would equal the 147 minus the 175 divided by 14. And the Z-score value for the right side, so we'll do ZR like that, would equal the 203 minus 175 divided by 14. And this is if you wanted to use the normal with a mean of 0 and a standard deviation of 1. That means the standard normal. If you want to use this distribution, you could do so, and you would use these Z-score values. So I'm not even sure what those Z-score values are, but I'll type them in as we go here. That's a 0. This is a 1. And what I should have here is 147 minus 175. And all of this would need to be divided by 14. And on the other side, I take almost the same numbers. This time I take, the only thing different is I changed the numerator of the 147 to a 203. And you see you get the same number that way as well. And so this one, what it does is it puts the normal distribution back at the origin. And so you're seeing it standardized or made to be the standard normal. So that's why we call it standardized to a mean of 0 and a standard deviation of 1. So either way, that's how you can get your answers there. Now let's take a look at number 2. It says the weights of 500 US pennies are normally distributed with a mean of 3.1 grams and a standard deviation of 0.14 of a gram, 14 hundredths of a gram. Find each probability. Okay, so this one, just to be simple, I could just type in a 500 here. No, I'm sorry. We have 500 pennies, but it's 300 or 3.1 grams with a standard deviation 0.14 grams. I'm going to remove these values for a moment. And I'm going to zoom fit this. All right, so here is our curve. Notice the area in the curve always equals 1. This is our PDF, or excuse me, CDF. The dark line right here, this solid red line is called the PDF. This dotted line is what we call the CDF, the cumulative distribution function or cumulative probability. Okay, so anyways, we want to know what's the probability that the penny weighs less than 3 grams. So that means the maximum would be 3. So we're looking at 3 or less. We're looking at this area, so I need to put it in as a maximum. That would give me the probability of having the penny weigh less than 3 grams, which is 23.7%. So at this stage, I can eliminate this because we know it's 23.7%. The penny weighing more than 3.3. So now we want to say it weighs more than 3.3. So somewhere over here. So to weigh more than 3.3, I would not put it as the maximum. I put it as the minimum. This is 3.3 or greater. The probability is, it looks like 7.7%. And at this stage, we get the answer. And let's just try C. It weighs between 3.2 or 3.4. So something in between 3.2 and 3.4. 3.2 and 3.4. When I look at this area, I find that it's 22.1% chance. 22.1%. And so the answer would be C.